All right, hey guys. So in this video, I'm just going to go over a quick mini lecture on mutable trees. All right, so to recap on trees, a tree is a nonlinear data structure where nodes are organized in hierarchy. And you can see this visually on the right here. A tree consists of two elements, a root node and a list of branches. Each branch can also be its own tree. And then each tree without a branch is considered a leaf node. So the right here, one is our root label. The node with the value one is our root node. And then it has branches 7 and 6. And then 7 can be considered its own tree, right? And then if we go down to 9 and 5, these are our leaf nodes. Okay, so this is the class tree that I directly copied over from your guys' lab. You can see this is basically object-oriented programming, right? The init method consists of the attributes of trees, right? The label and the branches. And then we also have a method is leaf, which checks to see if a node is a leaf or not, right? And then self.branches is set to a list of branches, right? Because trees are inherently nested lists of numbers. So if we go back here, 7, or this entire thing here is basically a list of numbers. 7 is also a list, but a branch of the root 1. So that's why here self.branches is set to a list of branches. Okay, so some differences between the abstract data type and also the class tree we're looking at right now is that previously we can just directly create trees now with tree label branches, right? See, we have this variable t that's set to this new tree that we created. And then to get a label of a tree or value of a node in our tree, we can just directly call t.label using dot notation. Before in the tree ADT, we'd have to call the function label t to get a value from a node. And then we also have t.branches. Before used to be branches t. And then t.isLeaf is a method within our tree class, right? And before we'd also have to call this function isLeafT in the abstract data type. Okay, so the main difference between the class/mutable trees and the abstract data type trees that we learned a couple of weeks ago is that now we can directly edit the contents in the tree directly, right? Without having to create an entirely new tree. And here, this block of code, we have this tree with a root node 3, branches 2 and 4, and then the branch 4 has its own leaf node 5. So if we call t.label, and t.label will basically call the root label since nothing else is specified. So t.label equals 5, then we'll directly change the label of our root node in this tree to 5. So previously in ADTs, we'd have to create an entirely new tree and set the root node to 5, right? Oh, sorry. But now we can just directly edit our original tree and set the root node value to 5. And then if we go into t.branches, 0.label, so the branches of our tree are 2 and 4, so the 0 index would go to 2. If we set the first branch value of our tree to 17, then that would just directly change the first branch value to 17, right? If we instead switch the 0 to a 1, then the branch with the value 4 would be changed to 17. Okay, so some tips for solving mutable tree questions. Most of the logic you applied to tree problems in the past will apply to mutable tree problems, right? So this is like 4b in t.branches is a way to loop through all the branches in a tree. Previously in ADT tree problems, it would be 4b in branches t. The typical base case, right, for solving recursive mutable tree problems is going to be t.isLeaf, right? Because there's nothing else that comes after leaf nodes. The only change is that you can modify the tree directly, right? We can set tree attribute through t.label and t.branches as we've seen the previous slides. And this is often done in conjunction with recursion. And one last thing is when mutating a tree, you don't typically return anything else unless specified in the problem. So when you're editing tree and editing the contents of a tree using the class tree, you won't really like return anything unless the question like specifies, oh, after you change like this label here, I want you to return the original tree with the changed label. So yeah, something like that. But anyways, I hope this video was helpful, and yeah, good luck on your midterm, guys.